All right. Welcome, everybody. This is the, I believe it's the 7th session of the USACE Sustainable Project Delivery webinar series. My name is Andy Temeyer, and I will be emceeing today's session on water. I'm going to introduce our presenter here. His name is Kirk Williams. He's the Chief of Mechanical Section for the Fort Worth District. He has been with the Fort Worth District for 12 years. He has extensive experience in sustainable design and development, commissioning, lead, energy modeling, and lifecycle cost analysis. He has served his career as a technical authority, subject matter expert, and designer on a wide variety of facilities for the DoD as well as other federal agencies. He's designed several buildings that have achieved LEED certifications. He holds a bachelor's degree in mechanical engineering from Texas Tech University, and he is a registered professional engineer in Texas and a certified energy manager. He's also a certified building commissioning professional. He was born, raised, and currently resides near Fort Worth, Texas. So without further ado, I'll turn things over to Kirk. As you guys, if you guys have any questions, I put a message in the chat box. Please type your questions, and we'll try to insert them into the presentation where appropriate. And depending on how long things go, we may have some opportunities for some open discussion at the end of the webinar. Kirk, it's all yours.
Okay, great. Thanks, Andy. So we'll jump right in. This is the water presentation. So we'll jump right in. Our objective with this module is summarize the strategies to comply with the Army's requirement to protect and conserve water. So pretty straightforward. So jumping into the next one, here are the resources slides. So some of these will look pretty familiar from some of the other modules. We have the Sustainability UFC 1202 that a lot of the modules are written around trying to achieve the compliance towards. We have a UFC here, 3210-10 for low impact development. We'll talk a little bit about that. There is the USACE Sustainability Microsoft Teams site where these presentations are going to be uploaded, as well as other content and forum discussion. Then there's the International Green Construction Code, the criteria formerly known as ASHRAE 189. So got renamed. So when you see IGCC, you kind of think 189 kind of. Then we have LEED Online. We will talk a little bit about LEED. It won't be real LEED heavy, but we will try to reference that as it comes up. And then there's the ECB, which is a great resource for looking at ways to better achieve LEED certification. So there's some great resources out there, and so I encourage y'all to take a look at those. And actually not listed on here is actually the ASA SDD policy. So the Army's policy, and the one that I'm referencing is from 2017. So you'll see that one kind of come up. It's not actually on the resource list here, but you can find that relatively easily. And I believe there's actually some information for that on the MS Teams site. Okay, so jumping in, today we're going to discuss protection and conservation of water, primarily geared towards the UFC 1202. And so the breakdown of the UFC and how it's structured is the first part is water, indoor water. So we'll talk about kind of the criteria that's applied to it. And this is kind of a high level, this slide right here is kind of a high level of some of the references to criteria that are cited in the UFC. So trying to be a little bit of a crosswalk here, but indoor water, we see that we're going to have some IGCC requirements, indoor water metering requirements, outdoor water, landscaping, outdoor water metering, alternative water, as well as stormwater management. Okay, so wanted to start out by giving a real world example of water conservation in action here. This is a sign from Hawaii. Don't fully know if it's joking. I've offered to go out to Hawaii to investigate, but haven't been given that opportunity to go run this one to ground. But just kind of started out with a little bit of a joke here of keeping the restroom doors closed so that way mongoose don't drink the toilet water. So real world water conservation. So why are we concerned about water? EPA WaterSense, they had some stats on there. Water is a finite resource. Even though 70% of the Earth's surface is covered by water, less than 1% is available for human use. Each day, the average American uses, on average, around 82 gallons of water at their home. Bathrooms are the largest use of water in the home, making up more than 50% of the indoor water. Approximately 5 to 10% of U.S. homes have easy-to-fix leaks that drip away around 90 gallons a day. Residential outdoor water use across the U.S. accounts for about 8 billion gallons of water each day, primarily landscape. And so it's an important thing. So water's going to get real important as we gear more towards resiliency. For those of you that have ever run out of water, you very quickly realize the need. I do backpacking as a hobby, and had several trips where we've come close or run out of water, and it gives you a real appreciation for when you can turn the tap on at the house and instantly have water. So you will notice if you run out. So we'll jump into the sustainability UFC here. First thing we wanted to point out was actually protect and conserve water. The first thing that it mentions is that we're going to make our decisions based on lifecycle cost. And went ahead and in the slide here, you can see the actual reference to the lifecycle cost section, and primarily the highlight where it says the water systems that will in total achieve energy and water requirements stated in the document. So starting out, the first thing we're going to look at is our cost effectiveness when we're making decisions here. We won't go real deep into the LCCAs. At this point, we're going to have a follow-on module where we talk that, but wanted to boil it down by kind of the starting point in the UFC is that we're going to look at the cost analysis as we're making our decisions. And a lot of people, that's pretty familiar. It's the same way with the energy and some of our decision making that we do. So just wanted to kind of point that out right from the start here on the water section. Okay, so next one is wanted to point out what the ASA SDD policy, they add a little bit here to it. The primary add that you would kind of see with this section is they add a statement about dual plumbing if cost effective. And so kind of see we're tracking along the same things of we want to implement strategies that conserve and intelligently use the resources, but we are going to base things on economics and cost life cycle cost analysis for our decision making. So one of the quick things going to want to bring up real fast is just talk utility rates. So some of you people may not be real familiar with water utility rates. Went ahead and included a sample of a water utility rate here. I think it's from Fort Hood area. Not real sure the time frame on it, but just kind of wanted to show kind of a default kind of what we might be looking at as far as how the rates are structured. Typically, the rates are going to be for something like thousands of gallons. And you can see that it's actually relatively inexpensive for some of these with your water rate. $4, and some change for 1,000 gallons. For an example, if you were flushing a 1.28 gallon per flush toilet, you could flush your toilet 781 times for less than $5. Relatively cheap utility in some locations. Primarily, important thing to note here is there's also a sewage charge. That may vary depending on your system type. If you were a standalone system and you had septic or something else, that would be something to keep in mind. But there's It's important to understand your billing structure, especially as you do lifecycle cost analysis and any other kind of analysis in your project. So it's a good place to start. Like I said, one, to kind of be able to point out what a sample rate structure might look like. And also just kind of wanted to highlight that, cheap water or, low cost water, it will make it difficult to implement, alternative water solutions and things. So if we're basing our decision making on cost analysis, if we have a really low utility rate structure, it will make it harder for us to implement, alternative features, especially if you have to, especially if you have to pump the water or you have to treat the water or you have to do any kind of thing that it's going to require operations and maintenance, because your baseline is going to be the potable. So there's some of the challenges that we would need to overcome for that. Okay, so kind of talk to the economics a little bit, just kind of, like I said, real high level, just kind of implement that we're going to do LCCAs. We're going to look at our rate structure. Rate structure will vary by your location. So definitely something to look into. And so now we'll jump into the indoor water here. And so as we talk about the indoor water up here in the parentheses is the USC reference that goes along with it. And then I tried to pull out some highlights for you. With this one, there's a lot more than we're going to actually be able to cover. So I tried to kind of overview a few of the ones that I think are kind of common applications. So we'll talk plumbing fixtures, appliances, HVAC systems and equipment and roofs, commercial food service and medical laboratories, and special water features. There's more out there, but just kind of for the sake of catching the wide majority, boiled it down to the ones that are highlighted in red here. So with the UFC highlights, we're gonna meet the IGCC building water use reduction requirements. We're gonna include EPA WaterSense labeled products, and then we're gonna meet the requirements for special water features if you were to have any, and those would be like ornamental fountains, pools, spas. So probably not a real common thing, but it may come up on some projects. Okay, so jumping into the IGCC, the plumbing fixtures and fittings. So some of the highlights from this section, we're going to put in low flow fixtures, and so this table is from the IGCC with the maximum flow rates. This will probably look pretty familiar to most people that have been doing design or implementing things, because this criteria has been around in ASHRAE 189 for a while. Definitely look familiar if you're used to working with LEED or a rating system like that. So it's pretty easy to find a lot of the stuff that will meet these criteria. Standard products usually fall in line with this. Just put in red for those of y'all that the UFC does allow an exemption for renovations for a higher flow rate for your water closet if you're using the existing infrastructure. So really, for the most part, these are pretty easy to find things. Definitely not the most advanced things, but pretty straightforward solutions as far as ways to implement water conservation and reduce the amount of water you're using at your fixtures and fittings. So plumbing fixtures and fittings continued. So I want to point out that the UFC 102 has a requirement. It lists the bottle filling station as optional, and the ASA SDG policy, it actually calls for the bottle filling station. So just kind of wanted to point that out to y'all. It's a little bit of a criteria chase down here, because the IGCC says you have to have it at 50% of your drinking fountains. The UFC calls it optional, and then the ASA policy actually requires the bottle filling station. So once again, I think that's been around for long enough that a lot of people know about it, but just kind of wanted to point that out, that there is a requirement for the bottle filling stations. I think you'll see that if you get into Division 22 plumbing spec. The other thing is it's got a requirement for using WaterSense labeled products. So WaterSense labeled products is a certification, and it certifies that the product uses at least 20% less water to perform the same function as a regular model. And so went ahead and put a picture here of WaterSense labeled. So you would see that usually as a sticker on your plumbing fixture. I'll say recently doing a bathroom renovation and purchasing a toilet and seeing that the price is pretty comparable between things that are labeled with it versus without, just residential style stuff. So it's good to see. And then there's also a link here on the slide for the WaterSense if you wanted to go take a look at that. So good resource online there. So appliances. So the IGCC has an appliance section. Some of the highlights from that are that we're going to purchase Energy Star clothes washers and dishwashers, and there's a maximum water factor listed for appliances. So once again, I think a lot of people are familiar with Energy Star, but looking for products that are labeled with that. Once again, it's an independent certification on the amount of energy that it would use. Went ahead and put the Energy Star website here as a resource as well. So a lot of those are probably pretty familiar things as far as the indoor water use goes. Okay, so jumping into the HVAC systems and equipment. So some highlights from the IGCC here are that we're not going to use once-through cooling with potable water. So a real simple example of something like this would be like the fans with the misters at football games. So that's kind of a once-through use. So it's not a real efficient use, obviously, because we're not reclaiming the water. Hopefully, it says potable water, so hopefully we're not going to use reclaimed or any kind of alternate water source if we're spraying it, especially in a crowd. So, but just kind of a highlight on that. Probably don't come across that real often, but it never hurts to point that out. Next one is minimum cycles of concentration for cooling towers. So for those of y'all that don't live and breathe HVAC, simple terms is this is how many times the cooling tower is going to recirculate the water before backwashing. The criteria has different settings based on your makeup water or the potable water that's coming in and the hardness, or like calcium carbonate. And so the typical ranges are going to be 3 to 5 cycles of concentration. Are going to be what you kind of see with the criteria. And, real world, I've seen good and bad examples of this. I've seen several towers that are using a cycle of concentration of 1 or less. That means that they're going through a lot of water. That water usually has chemicals in there to help prevent scale and growth and things like that. So you end up seeing some of these things where things aren't tuned real well, and they're going through a lot of water and they're going through a lot of chemicals, and it's just kind of all around not a good operation, and it gets pretty expensive. And then the last one is cooling towers and evaporative coolers, equipping them with makeup water meters, blowdown meters, conductivity controllers, overflow alarms, and cooling towers have drift eliminators. So these are kind of some real world things. This would be, checking to make sure that your design includes all these things. So some of them are, kind of real world things. So that way, how your system's actually performing. If you have meters, you can track how much is coming in and going out. Controllers for the conductivity, your water quality, an alarm. So that way, if a valve is stuck open and you're just overflowing and sending things to the drain. And then drift eliminators, which are, kind of a easy way to keep the water, in the tower. It sounds pretty simple, but just things that are real world applications. Hopefully people that are doing the cooling tower design or evaporative cooler design are familiar with these things and putting them in the projects, and nothing too crazy with all that. Okay, so the HVAC systems and equipment continued. So this one's probably one that might be a little less familiar with people. So the IGCC has a requirement for condensate harvesting. And so went ahead and put some images on the slide here, trying to a little bit depict what this might look like. So the map shows the average annual wet bulb. This value is actually different than what is actually called out in red here in the body of the paragraph, because it's talking about the 1% design condition. But just kind of for image, for being able to give an example, went ahead and put a map on here with the average wet bulb temperature, and what you would see is that to the right of the yellow line are areas where there's a high likelihood of this criteria applying. And criteria is that if you have a 1% design condition wet bulb temperature that's greater than 72 degrees, and you're greater than 65 MBH, which is approximately 5.4 tons, that you're gonna capture the condensate for reuse. So this is that would be a lot of applications, because most of our commercial stuff is larger than that. So just kind of my interpretation of this requirement, and other people might read it differently, is that condensate harvesting is an alternative water process, and that UFC 1200-02 section 2-4.3, the alternative water section, which we're going to kind of talk later, requires it to be life cycle cost effective. So
I give up after like 3 or 4 tries.
That would be important to find out. You could just be like,
I think we got a hot mic.
put it off.
15 minutes.
All right, I'm muted.
No, we're good. So anyway, so long story short is, there is this requirement. I think through our USC requirements, we're also going to kind of still base things on life cycle cost. So, if you don't have a customer that can support, the technology, or you have a really poor payback, or, you don't actually have a use, there might be some considerations there with that. The benefit with, obviously with capturing the condensate is, you have a water source that you're generating on site there. So if you have, a system that can use the water, then great. You can put that in there. You're obviously offsetting water that would be going to the sanitary sewer system. So that's great. The challenge is kind of like what we talked about with the economics portion are, usually this water is not going to be pressurized. So you're going to have to use electricity to move it, which is going to end up costing you money. And, usually this water is not going to be treated to any kind of content that you can actually, use. It's definitely not going to be potable. It will probably have a higher total dissolved solids content. And you might have some metals in there. ASHRAE's kind of been doing some research on the amount of copper and aluminum that are kind of available in this water, just because it's condensing off of, these metallic materials. So it might be a little bit of an uphill climb, if you're looking at installations where you have, you can get 1,000 gallons of water for $5, it might be a little bit of a climb. But with a lot of our sustainability, solutions, if you look at it just one item, it may be difficult, but if you look at it in a combination, so if you had, on-site cisterns or other uses, or you had, non-potable irrigation or things like that, then it can definitely contribute. And so definitely don't necessarily throw it out, but there's challenges, but if you can intelligently package up the solutions, then it could make for a great alternative as well. So the next one,
Kirk, did you see the question about condensate harvesting?
Yeah, it
Question
flashed
is,
up
would
real fast. So was it asking if
Would
it
condensate
was
harvesting
required
require an LCCA?
Yeah, so the way I read the policy is I would say yes. Others might read it differently, but I count condensate harvesting as alternative water, which, if you know, in that section with the UFC, it talks about being life cycle cost effective. So, but once again, that may be just kind of how I'm reading it. So, you know, I would leave that to, you know, to your SMEs or your, you know, authority having jurisdiction. But that's kind of the way I read it is yeah, I would base most of my decisions off of life cycle cost. Okay, great. So
Awesome.
we'll yeah, no problem. We'll jump into the roofs section here. So the highlights from this part of the IGCC are where we can use water on roofs. I know kind of indoor water on roofs is kind of strange, but I think the water goes through the building up to the roof. This is where they put it. So potable water and reclaimed water for roof spray systems. So we're not going to use potable water to cool our roof. So you can't run your sprinklers up on your roof to take load off. That's probably not a real common thing, but no evaporative cooling for your roof. In-ground irrigation systems on vegetated roofs using potable water or off-site treated water is prohibited. And then potable water and reclaimed water for irrigation after the vegetation establishment period is over. So those are some of the highlights on there. We'll talk a little bit on the irrigation here as we talk about the outdoor water. But those are some of the limitations that the IGCC puts on using for water for your roofs, and might not be a real common application, but some installations are using green roofs and things like that. So just some things to keep in mind there. So we'll talk real quick here. Just wanted to kind of said we talk some of the lead items as they come up. So Army's third-party certification method is LEED. And so LEED has requirements in the water category. Those of y'all that have worked with LEED are probably pretty familiar with this. So the prerequisite for LEED is that we're going to reduce our aggregate water consumption by 20%. We're going to have all of our fixtures are going to be eligible, or all fixtures that are eligible must be WaterSense labeled, and we're going to install appliances meeting the Energy Star requirements. So what you can see here is, you know, if we're following the UFC and achieving all of the requirements, it should be real easy to get the LEED prerequisite. So nothing real crazy here if we're following the UFC. And then getting into the actual credits. So LEED is going to give you credits which, you know, count towards your certification. And the points are going to be based off of based off a calculator to determine the savings. So here's kind of an example in the picture of a calculator comparing the baseline versus the design. So at 25% water savings, you get a credit, and then it usually goes up at 5% intervals up to 50% where you get 6% credit. And so this is kind of the plug for alternative water, is it actually counts towards these savings, and it will help you achieve like exemplary performance. So it you know, kind of old school reference here is if you had Super Mario, you eat one of the mushrooms and you grow bigger. That's kind of what alternative water is going to do for you with this credit. Is it's going to make you grow bigger, and you'll get more bang for your buck out of this with the LEED. Okay, so we'll jump into indoor and outdoor water metering. So the UFC highlights that we're going to install advanced water meters to monitor building indoor potable water consumption. There is a DoD utility metering policy, and that's the link on the slide right there to the policy. And then the meter configuration is going to comply with the cybersecurity UFC. So we don't want to have someone hack the government through the meter. That would be bad. So, you know, providing meters, having them connected, as well as having them included in cybersecurity. So it's kind of just a logical thought process of if we're going to ensure conservation, a great way to know if we're conserving is to know how much we're using. I'll say as a mechanical engineer, there's two things that I really love. Those are isolation valves, so that way you can turn the thing off, and meters, so that way you can know what is actually going on. They're tend to be cheap troubleshooting for the real world. To give another quote here, you know, I'll go back to G.I. Joe, and knowing is half the battle. So if you know how much water you're using, that can be a very helpful thing. As you probably saw with the cooling towers, you saw that we had several meter requirements, so that way you could figure out what's going in and what's going out. Vitally important for troubleshooting. So the photo at the bottom there is also from the ASA SDD policy on utility metering. And if you look at the last sentence, it actually says you're going to provide sufficient meters or leak detection on the distribution systems to identify system losses. So it's a good idea. So know or have the means to determine if your systems are leaking, which is a great way towards our achieving our goals of conservation is know if we have a leak. Okay, and so we'll jump back into LEED with metering. Once again, LEED has requirements for metering. We're going to provide permanent meters, so that kind of makes sense. Is we're going to actually leave the meters there. And then the other requirement would be sharing the whole project water usage with USGBC. Important note on this is DOD has a waiver that we don't have to do this. So I believe that's on the sustainability website. And so that's hopefully pretty common. That's been around for a while, but we are not required to share our data with that for security reasons. But we can still meet the metering requirements. And so that would have been the prerequisite. So here would be the credits. As far as the metering is concerned, as far as the credits are concerned, metering is a fairly cheap, simple solution to get LEED credits. I've seen several projects where they aren't going for metering because they don't want to have a meter cost, but they've upgraded and done extra measures for their HVAC systems, to chase, energy savings and LEED points. And so you kind of see on this one hand of it's fairly cost effective. We have, DOD policy pushing for metering, but they aren't implementing it because they don't want to provide extra meters. The LEED criteria here is calling for two or more meters on the following systems. So, the irrigation, we'll talk about that a little bit later. The indoor plumbing fixtures and domestic hot water. Recommend you read the LEED reference guide because there are specific things that are required to be with that. It's not just putting it straight on there. So there's a little bit of rules with that. So if you're going to go that route, make sure you've read up on it. Reclaimed water and other processes. So this is another one that I've kind of seen, people that have had reclaimed water and things, and they don't want to put meters on there because they don't want to have that added to the first cost. But I'm a proponent for it because I think kind of like if you've ever seen the bottle counters with the water bottle filling stations where it says, here's how many, plastic bottles have been diverted from a landfill or whatever, it can almost be like that. It can be kind of a feather in your hat for, here's how much water we've actually saved by using alternative source rather than potable. So promote that, but once again, I'm 4 meters because I think they're a cheap, cost-effective way to know what's going on. So we'll jump into the outdoor water. The UFC highlights for this section, potable water's prohibited for irrigating new landscaping other than plant establishment. Existing systems with single water meter, reduced combined indoor and outdoor potable water use by 20% compared to a 2007 building. Showing preference for irrigation contractors who are certified through the Water Sense Label program or under other industry recognized credentialing program. And then there's a reference to a landscape architecture UFC for additional requirements. So pretty straightforward things with that. So jumping into LEED also has requirements. So these would be the prereqs for the outdoor water use reduction. So the intent is reduce outdoor water consumption. That's pretty straightforward. Reducing outdoor water use through one of the following options. So no irrigation required or reduced irrigation. So once again, pretty straightforward. I think those individuals that deal with the design on this are probably pretty familiar with it. And then the credits kind of follow suit of, there's two options. Either you have option one where you have no irrigation and you have the potential for 2 credits. And option 2 where you have reduced irrigation and the 2 credits are based on the percent of comparing the baseline versus the proposed. Similar to what we had probably for the indoor water use, you would have here for the outdoor water use as far as documenting the savings. So now we'll jump into alternative water. Here, I'd like to start by talking about the definitions, just to kind of keep things clear. So on this page, the potable water definition here is from the 2016 plumbing code. And you can see that it's water that's free of impurities and that, it's not going to cause disease, psychological effects, bacterial or chemical quality. So, public health essentially, and that it's going to meet the authority having jurisdiction. Hopefully that's not surprising to people. And then just kind of show that the picture here kind of for some perspective is of a temporary water connection that they brought in. They were actually adding a building to the well system. And just kind of wanted to point out that, just kind of looking at the truck here, you don't see that it's labeled potable anywhere and the material. So not real sure about the application here, but likely not a potable source hooked up. So not a great real world example, but being careful of what we're doing with our water and keeping public health and safety in mind. So here's some of the other terms that people might not be quite as familiar with. Hopefully people are familiar with potable. So non-potable, water that's not safe for drinking, personal or culinary use. Alternate on-site non-potable water is non-potable water from other public utilities, on-site surface sources, subsurface natural fresh water sources. So examples could be gray water or on-site reclaimed water, rainwater, condensate, or water from a reverse osmosis system. And then you also have gray water, which is water discharged from lavatories, bathtubs, showers, clothes washers. And so things like that. So some of the other kind of terms for alternative water that might be out there. Just kind of want to highlight the picture here. This is one from a barracks that we did that we were using non-potable water for toilet flushing and some of the signage that was required by code telling people not to drink from the toilets. So just kind of the requirements that are applied. So, kind of in suit, it could have said, keep door closed so that way occupants don't drink from the toilet to kind of match the mongoose sign. But a little bit different, but kind of the same. So make sure you have the signage there to protect and public safety in mind. So going along with the alternative water, so here's kind of where I pulled the thing for the condensate harvesting. This is where we talk about alternative water, and we talk about where life cycle cost effective, as well as permitted by state and local laws and regulations. We can use alternative water for non-potable applications. So this is kind of where that came from, is this section of the UFC. I'll say, basing your water on economics, like I've kind of already mentioned, is kind of challenging. We had a project where we were going to get kind of class 2 reclaimed water, which is kind of water that's from a sewer treatment plant that's not been treated all the way to potable conditions. And it was going to be pressurized and distributed to the site. And the utility actually said that it was going to be free. And even just kind of trying to get it in the project with just having the connection and minimal dual plumbing infrastructure was going to actually be a challenge. The non-potable water was going to need to be about 50% of the cost of the potable water to actually have a minimum payback. And so even just having a connection in there without even having to pay, pumping or treating or anything like that, or really even O&M, gets pretty difficult when you're dealing with low-cost utilities. But we might see some of that change as we get more into resiliency. So obviously, water is a vital resource, as we kind of pointed out. And so, if the decision-making gets away from economics and gets more towards availability of resources and things like that, that could very quickly change some of the decision-making. But currently, the way the policy is written is around lifecycle cost and economics. So as we're discussing alternative water, just kind of wanted to have a slide kind of highlighting some of the state and environmental quality regulations. So you noticed how it said, if you could do it per the state jurisdiction. So just kind of a heads up of states have different environmental quality regulations with these alternative water uses. So very much this is something you would want to research prior to really getting into it, because different states have different allowable uses and they have different requirements. So this is just a quick comparison from a project comparing Texas and Oklahoma and how you have different uses. Typically the classifications, 1 is more pure going down to 5, which is less pure, and you can kind of see that with some of the allowable uses. But you would, as you're looking at these things, you'd want to look at your classifications and what you're actually allowed to do in your area, obviously prior to, performing economic analysis and things like that. So research is good. A great resource is AWWA Manual N24, which is planning for the distribution of reclaimed water. So if you get into the slides and you look at the notes, actually have some links to some of that in there. So, but there's a lot of resources out there, but I'd say, look for your local region. When you're looking at solutions. So some alternative water, so some kind of common non-potable sources. So kind of like I mentioned previously, sewer treatment plants, they actually have outlets at different parts of the stages of the processes. So sometimes they have parts where they can outlet water at that's not fully potable. And sometimes they will try to sell those up cheap. I think a lot of people are probably familiar with that. Typically, you'd see that's the purple pipe going to the golf course kind of thing. That tends to be kind of the common thing among some of the installations is the golf course gets the reclaimed water. So that's a great one. Sometimes it's seasonal, so something to be careful of is if you're banking on a resource like that is knowing if it's going to be not available at different times of the season. There's obviously rainwater. The IPC or the International Plumbing Code is a great resource for planning your rainfall. There's chapters on that, as well as chapters on non-potable rainwater requirements. So once again, a great one, and that's a little bit what this photo is here of capturing rainwater and diverting it to a tank for use. You have condensate, which we've talked about. You know, we have the requirement from the IGCC on capturing it. ASHRAE, American Society of Heating and Refrigeration Engineers, it's another great source on condensate harvesting and some of the water quality that goes along with that. And then you have gray water, which is captured from the building plumbing fixtures. We've talked about that, you know, sinks, showers, things like that. So some common sources, and a lot of facilities have these things, and it's determining if you have solutions that can be implemented with them. So with alternative water, just wanted to emphasize backflow prevention. So alternative water has a tendency to be intermittent. You know, if we're basing it on rainfall or condensate or things like that, we will have times a year where we may not have this water source. So usually in those kind of conditions, you would back it up with a potable source. And so if we're going to go potable water and we're going to connect it to a non-potable source, we want to protect the public health and safety. So we want to have backflow prevention to prevent cross-contamination. So very much recommend researching that, but some common types of backflow prevention are air gaps, you know, so obviously not allowing it. So if it tried to backflow, it would go out of gap. Reduced pressure backflow preventers. That's what is shown in the kind of top right. With the blue is your backflow preventer, and then the photo is limiting cross connection. So the photo kind of in gray. If you look at kind of where the left is of the photo, you would actually, this is a potable water connection to a non-potable source. And their cross-contamination plan is that they would actually have to physically unbolt the elbow and turn it to be able to connect up to the other source. So it won't physically fit a T. So that way you don't have someone that just kind of accidentally opens a valve and cross-contaminates. So very important. Recommend researching that. You know, and obviously our job is to protect the health and safety of the building occupants and the public. So keep that in mind. Take it serious. But there's a lot of great resources out there. The AWWA manual, as well as some other things, have some real great real world applications. Your state environmental quality will also probably have requirements for protecting, as well as your plumbing code and things like that. So continuing on with alternative water. So we've talked a little bit about why it's so cost effectiveness. Some municipalities or areas will require treating of the reclaimed water. So they might require a dye or something like that. So that way, if it does have a leak or cross-contamination, it can become known. So just something, once again, to have researched prior to doing your cost analysis. The example here is of a packaged skid for a cistern, as well as a pump system that goes along with it. So you can see that there's quite a bit that can go into treating alternative water sources, as well as pumping it to get it for distribution. So just a couple of recommendations prior to actually implementing these solutions are, I highly recommend you talk to your operations and maintenance personnel or your installation, because they will be the ones that maintain it. And these, you know, these do need to be maintained to keep safe, healthy, you know, water environment. And then also just being able to have these in mind as you're performing your economics, because once again, your economics will drop very quickly if you have to add systems and account for maintenance and other utility costs. So stormwater management. So here, the UFC basically refers to the UFC for low impact design development. So low impact design development is stormwater management strategy designed to maintain the site hydrology and mitigate the adverse impacts of stormwater runoff and non-point source pollution. So in short, LEAD seeks to manage the rain in a boiled down sense, beginning at the point where it falls. So trying to maintain the pre-development hydrology. So goes into the UFC 3.2.10 and the applicability. Just one of the things to kind of highlight with this as far as applicability goes is that the UFC applies if both of the following apply. And so it talks about your project construction or expansion of the building as well as the footprint. So anytime you're adding in UFC criteria, I always recommend reading how it applies. That's a great first stop at determining your criteria is, does it apply to your project? And then just kind of a graphic from the low impact development UFC on determining compliance with ISO 438. Once again, probably those that deal with this on a daily basis are probably pretty familiar with it. And then just highlight some of the on-site LID solutions, bioretention areas, permeable pavements, cisterns and recycling of the water, as well as green roofs. So some of your possible on-site solutions, to help meet the requirements that go along with that. So as we're kind of wrapping this up here, just kind of a course or summary recap here is we talked about the water requirements from USC 1202. Our goal is to protect and conserve water. We have indoor water requirements. We have indoor metering requirements. There's outdoor water requirements for landscaping and then there's outdoor metering requirements. We talked quite a bit about alternative water, and then very briefly on some of the stormwater management. So that kind of concludes what I have. So if there's any questions.
Thanks, Kirk. Kirk, sorry. If anybody has questions, you can go ahead and type them in the chat box, or we have a couple minutes here. If anybody wants to ask a question, you can turn off your mute. Seeing some thumbs up and some congratulations. Well, if we don't have, oh, here's one. Annette Stump has one. Do you ever get a rainwater harvesting to be life cycle cost effective?
Personally, no, I haven't had one. I think if you had cisterns or something like that, if you had a kind of an LID use, I think that would very quickly probably start to be cost effective if you had a need for that. I'll say a lot of the stuff that I've dealt with, we've had quite a bit of site for retention. So that route, we have had concept one where we put in the design for a treatment system that Wahasu, or I'm probably butchering the name on that one. But it was very much not life cycle cost effective because we were pumping it and we were dyeing it and we were treating it, but it was kind of a pilot project. So it was kind of given the thumbs up for implementing the technologies rather than the cost.
I think that probably varies widely depending on what region of the country you might be in and stuff like that. I feel like we did a project, I think it got canceled, but in Seattle, where we were looking at some rainwater harvesting as being lifecycle cost effective. But I'm not sure if there's anybody on the line from Seattle that can chime in on something like that. But then Vincent Song had a question about can we use wireless urinals?
I would actually have to look that up. At one point in time, there was a criteria to use them, and then they got rescinded. I don't know if it says you can't use them, but I would very much check with your operations and maintenance personnel.
Yes.
People have a tendency to not like them in application.
So the long story on that is that it used to be mandated on Army projects for a while, back in the Army transformation days. And I believe that policy was rescinded. I'm not aware of a prohibition on them, but they tend to not be favored by the DPWs. They're maintenance intensive, right? Oh, and
That's my understanding.
But it can, because they don't get maintained.
Yeah, and I would definitely keep some kind of waste plumbing to them so that way they can be flushed. Because I would not just set them. So, because yes, like Eric said, they will smell.
Kirk, do you see this question about does it?
No, go ahead. Yeah, so Dan, that question tends to get asked whenever we teach this prospect course, and I don't know. At one point in time, I think they are actually looking into that. But I don't know for sure if they have actually gone back in and updated the 100 curves on those. Yeah, there's a lot of alternative toilet types out there. If you ever get into that kind of thing, there's a lot of solutions out there.
Awesome. Well, we're 2 minutes before the hour. I think we can probably wrap things up. Thanks, Kirk. Thanks, everybody, for participating. And we have another one of these next week. Just trying to look up what one it is. I'm pretty sure I'm presenting. So, it is on project delivery. Everybody have a great day. Thanks.
Thanks.